What's up YouTube? Today we are creating our own sequences in Bitwig's grid. So you're probably wondering, why are you creating your own sequencer from scratch? Why don't you just use a normal sequencer like a normal human being? We don't need that type of negativity here. You obviously don't know that on this channel we do like to just explore some random ideas. I feel like this type of thing you can learn a lot from. You know, building sequences, you can learn a lot. Maybe not only in terms of how to create your own unique devices, but also in terms of how other devices are created and thus create your own concepts. Maybe that's outside of the world of sequencing. Maybe you want to somehow sequence modulation inside a synth or something like that. Let's talk about an interesting way to create your own sort of pitch and gate sequences from scratch in the grid. I don't mean using the steps and the gates modules. That's lame. We're going to actually do it from scratch using just logic modules and phase things. Anyway, let's dive in and have a look. Okay, so like I said, on today's agenda, we are creating a sequencer from scratch in the grid. So what I want to do is I actually want to create this in NoteGrid so that I've got a kind of my own unique sequencer that I can use to feed to any device. So say, for example, I've got a patch in PhasePlant and I want to create a melody for that patch. I can just create a sequencer or use a sequencer that I've created for all sorts of interesting ideas. You're not limited to just sounds from Bitwig's grid this way. So what I'm going to do, just for argument's sake, let's put in an instance of Vital, and I'm going to pull up a preset here real quick. At the moment, nothing's happening. We've literally just got the MIDI feeding through the note grid and into the patch. So I want to create a system which basically can generate notes inside the note grid and not only edit MIDI coming through. So to do that, we need to set the voices to mono, and this allows us to actually create sequences in the note grid. So what I want to do is I'm just going to be removing this for now. We can still get back to that a little bit later on in how to use the pitch input to transpose the sequences and stuff that we've created. So you're probably thinking, you know what, the easiest way to do this is just put a gates and put a steps. Okay, we've done it. You know, we've created a sequencer. But that wouldn't be a very interesting video, would it? So what I want to do in this video is explore a couple of ways in which we can use just primitive devices like logic modules and stuff to create something that is very similar to a step sequencer. And then we can create something that's very similar to a gate sequencer. Okay, so just to start things off, I want to just put in some MIDIs so that, or at least some pitch modulation, so that we can start working at the grid sequencer or the gate sequencer, and it's not so boring while we're working on it. So what I want to do is I just want to quantize the pitches coming out of here to a specific scale, which we can set. And then what I want to do is I also want to put a pitch scaler in between, and that can be used to determine like how many octaves we're playing with. So here, for example, now we've created a sequencer, but how boring would it be now if I just said, okay, video's over, next. So what I want to do is I want to create this again using primitive devices. So the idea with this is to use the merge module is the easiest way to do this. And what we can do is we can get this to have 8 input ports. So each of these ports corresponds to a value input, and then you can use a signal to send whichever one of these values to the output. So what I want to do is I'm just going to put a value over here as the input, and then what I want to do is I want to put 2 buttons over here, just so I can outline exactly what's happening. So now we have 100% and 0%. I actually want to just set this down to 2. And so now when we sweep this value, what we can do is we can actually say put an oscilloscope after this so we can see exactly what's going on here. And now if we sweep this value, notice how it goes from 1 to 0. We want to set this merge to nearest as opposed to linear, so it doesn't actually interpolate the values. It just switches from 1 to 0, right? Are you guys getting this? So now if we set this to 8, and we just duplicate these buttons a bunch of times, connect them to these inputs, we're essentially creating a gate sequencer where this value becomes the sequence selector or the phase of the sequence. So let's just punch in a bunch of random values here on these buttons. And now you can see it actually steps through these values as we increment this. So for those who remember the video that I recently did on the Turing machine, you'll remember the very vital module called the counter. And we can use this for exactly the task we need here, to literally step 8 times between these different binary on and off values. So let's say, for example, put in a triggers. This is basically just a clock but smaller, so we can use this to step between these values. Do you see this? So what I want to do is I actually want to set this to 16, so that now we're a 1/16th step sequence that basically has 8 steps. Are you guys following? So now what I want to do is I want to send this to the gate output. So notice here how these values are stepping, and it's also not stopping when we press stop. So these values are stepping over here. Let's set this to mute when stopped so that we can actually trigger that. And what I want to do is put a transport and set this to trigger the reset of the counter. So now every time we start, it basically resets that sequence. Do you see that? So notice how it ties these notes together. For example, if you have 3 gates in a row, it treats it as one long gate. We may not necessarily want that, or we may want it. We could set up some kind of system that's going to switch between whether we want that kind of raw 16th clock, or whether we want to tie those 8th notes together. So this is a little bit confusing, but the easiest way to wrap your head around this is, let's just say, for example, we want to set up just a 16th clock. What we want to do is we want to set it up so that we have an AND that generates both the gate coming out of the sequence, and it ANDs it from the actual clock that's clocking the sequence. And the resulting output will be, basically, we can actually compare them in the oscilloscope over here. You'll notice that the output from the AND is basically shorter. It's half the time. Let's send this here. So what we can do is we can set up a switch that's going to switch between whether it's ANDed or not. And that way we can choose whether we have something that's ties the notes together or just plays the raw clock. So let's send the output from this into here, and then we can create a button that's going to be the tie button. Okay. So you've probably noticed that there's a limitation in the merge module for 8 inputs. So this is a little bit of a drawback. However, what we could do is we can actually create 2 of these systems and then just use a selector to select between them, and you flip-flop that at an 8th timing of the clock or of the counter. So let's see how we would do that. Let's just move some of the stuff up a little bit over here. So let's just copy paste this entire sequence, and we want to counter this into the select as well, or into the merge as well. So now these are synced, but we want to flip-flop it so that it plays the one and then the other. So we can use another select, right? We can pop this over here. And then let's say we want the first one, and then the second one, and then from here, we're going into that and into that other select, which chooses the ties. You can actually just take away this oscilloscope for now. And then this select module needs to be kind of driven by another counter. So let's just copy paste this counter. And this one, we actually need to use a separate trigger, which is set to, I believe, 2. But let's just double check this. We also want to reset it from the transport play, and we only want 2 steps in this counter, and this is going to go to the select. I think this should work. Yes. So the maths behind this is that there's 8 steps, and if the clock is 16, you'd need to divide that by 8, and then the resulting number is 2. So the clock division then becomes 2 to actually count between those 2 sequences. So that's it. We've created a 16-step sequencer. So what we can do is we can actually just do a little bit of housekeeping, just to make things a little bit easier, to understand, because we may not necessarily want these two massive things here clogging up the interface. So we can actually move these out of the view and then have just the buttons kind of like lined up this way, horizontally. So it's important to remember the sequence of buttons here and not jumble them up, because that will completely throw off, you know, what's that you're planning with the sequence. So we've got the two rows, and I guess visually it'll be a bit easier to read, you know, when you're actually punching in the different sequences this way. And I want to show you a really cool little trick. Once we've kind of got the whole sequence, or once we've got the whole engine going, a really nifty trick that you can use to basically just have like macros assigned to all of the parameters, so you don't even need to open up the grid. You just hit some buttons and it does its thing. So let's just clean this up a little bit over here. Goes there. That goes there. Can actually just move all of this stuff back a bit. So this is our gate sequencer. Okay, so we've passed the hard part, or the kind of main fundamental logics of the patch. Now it's all about just taking this idea and expanding it to fit into various different ideas that we may need. So let's copy this whole thing and paste it over here, right? And now with each of these buttons, what we need to do is literally just drag in a value module and pop it on top of the button. And now each of these, instead of just sending a binary value of on or off, it's going to send an actual kind of incremental value of between 0 and 100%. And it's going to step through that exact same sequence in the same manner that we created. So this is really cool, because we've created the kind of, how can I say, the logic and the engine of the sequencer, and now it's just about like how we want to play the sequencer. Do we want values or buttons or that kind of thing? And it's just minor tweaks from here that are going to get the patch going. So here, for example, we don't need the tie system and the and system. It's going to come directly out of this select over here. Obviously, because we want the raw values, it's not binary anymore. We can actually just remove this system that we've created with the and the clock and just send this from the select into the pitch scaler that we created earlier. So let's just try this out, or do a bit of housekeeping here as well. So we could take this idea of the pitch sequencer and then expand that to velocity as well. So let's just copy this whole thing, paste it down here, and now this can become our velocity sequencer. So like I said, with these like big things, we can actually just move them out of the way, because we don't need these to be visible in the patch. That's just our kind of routing and stuff. And now we can kind of go in and clean things up a little bit more in terms of the housekeeping. So there's various directions we can take this. We could create some kind of randomization system. So I actually want to put in a trigger device, and what we can do here is put in dice on the trigger as well as a modulator output. And then this, what we want to do is we want to actually just duplicate it a bunch of times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. In fact, half of them, let's put up at the top. So this is going to be like our randomizers for the gates. Copy paste this whole thing so that we have randomizers for the pitch as well. So now let's go in and turn all these buttons off. and all of these values down to 0. And then this is a little bit painstaking, but I'm going to just fast forward this so you guys can bear with me for a few moments of your precious time. And so here with the gates ones, let's just select this, modulate this. Next one. So here it doesn't matter which one is going to which one, because it's all just randomizing anyway at the end of the day. Okay, so let's prototype this. See how it randomly selects a sequence for us. That is so cool. So you could potentially, like I said, you could create macros here. You can also create buttons as modulators, which is really, really cool. And it's expandable. So you could have 16 buttons. Those correspond to the buttons over here, for example. The problem with doing this, though, is we want to think about this before assigning the modulators. So for example, let's actually just remove these. And then you want to modulate the button outside of the system. Does that make sense? So instead of randomly modulating these ones, we want to randomly modulate the outside grid modulators. So let's just unassign these and then assign them to the buttons instead. See how cool is that? Now we have like a visual idea of what's happening inside the patch with just the outside macros. Okay, so now how do we get it so that it transposes to the incoming note? It's literally just as simple as taking an add math module and sending the pitch to that and sending the pitch output from whatever system you've created and then sending it back there. So now if we put in a MIDI, for example, I'm going to put in a clip over here and let's say do it on F, it should transpose that sequence to an F. And like I said, the beauty of this is now it's like outside of any plugins. We can just go and cycle through some presets. Awesome, so that is about all that we have time for today. I hope you guys enjoyed that. Let me know what you think in the comments. I'm going to be posting this preset or this Bitwig device of the sequencer that we've made together to my Patreon for all my $5 supporters. So if you want to know what that's all about, check out the link in the description. I think that's about it. I'll see you guys next time. Cheers. Oh yes, one thing. Please, don't forget to hit that like button and hit that subscribe button. I'll see you guys next time. Cheers.